Settle down, sit down. You're in for a treat. All right. So I want to start off by asking you guys a simple question. So has anyone been completely lost when they first started their blockchain development journey? Anyone? Hands? Yes. Well, I was afraid I was going to be the only one. Well, let me tell you guys my story, what it went down for me when I first started. I wanted to build a decentralized application. So I was like, okay, I'm gonna go online, gonna do some research, and I found out there were dozens of blockchains that claims to be the best one. So I spent time to do some research to figure out the strength and the weaknesses of each chain. And after that, I had to learn the smart contract languages and the SDKs of that specific blockchain. And even then, I had no idea where to put the smart contract that I built in a full application. So why am I telling you this? It's because I don't think I'm the only one who will struggle with this. In a Web3 application, there's so many moving parts that a developer have to have a fine understanding of before they start coding. But oftentimes, these parts are taught separately, and it leaves developers clueless and confused when they first start. And this has to change. Hello, my name is Chris Kim. I'm a developer advocate for Algorand, and my goal is to make developing on Algorand as simple and easy as possible, and hopefully train millions of Web3 developers. I strongly believe that having a high-level understanding of all of the moving parts that goes into a decentralized application is a critical first step of becoming a skilled Web3 developer. So after this presentation, you will have a complete understanding of what dApp development looks like on Algorand, and you will be able to build out your ideas, your dreams, on one of the most scalable, secure, decentralized, and green blockchain out there. So let's first talk about what Algorand is. Algorand was founded in 2017, and the mainland launched in 2019. It was founded by Silvio Micali. He's an MIT professor in cryptography, and he's also the Turing Awards winner. For those of you who don't know what Turing Awards is, it's basically a Nobel Prize for computer science. He's also the co-inventor of zero-knowledge proofs. So have you guys heard of that? Zero-knowledge proofs, ZK snarks. That is a cryptography technology that is widely used for a lot of the blockchain protocols and the applications in here. And he's a co-inventor of that, so he's a legend in cryptography. He's also the co-inventor of verifiable random functions, which is heavily used for the Algorand protocol. But we'll talk more about that later. So let's talk about some general Algorand strengths. Algorand is fast. Currently, it can do 3.7 seconds transaction finality. And when I say transaction finality, what I mean is when you send a transaction to the Algorand blockchain, it gets added to the block. It takes 3.7 seconds to be included in the blockchain. And when it's included in the blockchain, that transaction is final. You don't have to wait 6 or 7 blocks to make sure that you're on the longest blockchain. No, as soon as it's on the blockchain, it's final. And this is a critical feature for applications that provide services that are time sensitive, like financial services. Algorand is scalable. Currently, it can handle up to 6,000 transactions per second. And to give you guys a reference, Visa's transaction per second average on a global scale is about 1,500 transactions per second. So that means Algorand is suited for global usage and mass adoption. Algorand is decentralized. It uses a unique pure proof-of-stake consensus protocol. So there are 2 reasons why Algorand is decentralized. One, for pure proof-of-stake, the entire network is participating in the consensus protocol. One of the most popular proof-of-stake is delegated proof-of-stake. And in that, only a small group of accounts, nodes, are selected to participate in the consensus process. Now, that allows that chain to be fast. But what they're sacrificing is decentralization. That means attackers have less accounts to attack. And there's a higher chance of the attacker to figure out who the next block validator will be, causing a security risk for that chain. But for PPOS, for Algorand, that is not the case. The entire network is responsible for consensus, and that makes it nearly impossible for any attacker to know ahead of time who the block validators will be. Second, with PPOS, there are multiple voting rounds for the consensus process. And for each round, their group of nodes are selected randomly using the verifiable random function. Now, thanks to the power of verifiable random function, or VRF, everybody in the network has a chance to be selected in the consensus process. Just to give you an example, a couple months ago, an account with 5 algos was chosen to participate in the consensus. So that means Algorand is very decentralized, and it also makes Algorand secure. Algorand has been live since 2019 for over 3 years, and it has never gone down for over 24 million blocks. Algorand is a layer 1 blockchain. It's the base layer of the Web3 ecosystem. And on the Algorand blockchain, there will be billions of dollars locked on top of it, along with hundreds of companies building on it. It is not a question for the layer 1 blockchain to go down. It is top priority to always stay online. Algorand is green. It's been carbon negative since 2021. So what do I mean by that? Algorand, by design, and thanks to the pure proof of stake, it uses very little electricity. But we went a step further. We partnered with Climate Trade to offset all of the carbon footprint that we output by purchasing more carbon credits from them. So that means Algorand is actually helping the environment by it existing. So those are some general strengths of Algorand, but let's dive deeper into some unique features that the Algorand protocol provides. So on Algorand, if you want to create your own coin for your company, you don't need to create a smart contract like ERC20 or ERC721. You can create your coin just by sending a simple asset creation transaction to the network, and your coin will be created. So it's inherent to the protocol, and those coins are called Algorand Standard Assets, or in short, ASAs. So this is good for 2 reasons. One, there's no chance for you to introduce a bug into your contract or into your coin, because it's just built into the protocol. And second, it's just easy for any developers to build a coin, an NFT, or whatever asset they need on the Algorand blockchain. Algorand also supports atomic transfer. So what does that mean? That means it can handle multiple transactions simultaneously. And if one of the transactions that's in the group fails, all the transactions that's in the group fails as well. So this is great when you need to have simultaneous transactions. When 2 parties are trading, both parties have to obey. And if one fails, the other fails as well. Algorand also is a non-EVM chain. We have our own virtual machine called Algorand Virtual Machine. The Algorand Virtual Machine is fast, secure, and low cost. But we're going to talk more about this later on, and on why we decided to build our own virtual machine. Lastly, Algorand recently released an update to introduce Algorand State Proof. So what is this? Algorand State Proof is a post-quantum secure, trustless interoperability tool. So do we all agree that the future is interoperability, that multiple blockchains will survive, and they need to be connected? All of them will have their own uses, and they need to be connected to make blockchain the infrastructure of the world. But we had problems with those bridges recently, those major hacks. Why did that happen? Because those bridges are a centralized third-party entity that these blockchains had to rely on, that they had to trust on. What if I tell you that you can connect 2 blockchains without having that middleman in the middle, and 2 blockchains can prove the state on the other blockchain with this state proof technology? So all proof-of-stake blockchains can implement their own version of state proof, as this is an open source technology, and we hope that in the near future, state proof will become the industry standard for interoperability. All right, now let's talk about what an Algorand dApp architecture looks like. This is to give you guys a high-level overview of what the architecture looks like for a dApp. So this is a simple Web 2 app architecture. This is something we're all familiar with. And we have a front end where the users interact with your application. Then we have the web server in the middle that handles all the API calls from the front end to the back end. And then we have the database that stores all the relevant data that your application needs. Well, the Algorand app architecture doesn't look too different from that. It still has those three components, and all you're adding to that is the Algorand blockchain. And on the Algorand blockchain, you deploy what's called a smart contract. And smart contract is basically a program that lives on the blockchain that handles certain transactions based on certain conditions. And that smart contract is executed, evaluated with the Algorand virtual machine. To interact and deploy the smart contract, you use the Algorand SDK, either directly from the front end or directly through the web server. Today, we're going to focus on these parts, the blockchain aspect of a dApp. All right, let's dive deeper and look what the diagram looks like for the blockchain part. So we have the front end, and the front end uses the Algorand SDK wrapped with the Beaker framework to deploy and interact with your smart contract. And the SDK uses what's called an ABI, which is a standard that tells you, hey, this is how you interact with your smart contract. On the Algorand blockchain, you write your smart contracts using PyTeal. PyTeal is a smart contract language on Algorand, and that is also wrapped with a Beaker framework to make your code familiar for any Python developers. Now that contract gets compiled down into a Teal program. Teal is an assembly-like language. It's a low-level language that the virtual machine can understand easily. And that gets compiled down into bytecode, and that's where the Algorand virtual machine does its magic. It evaluates it, and then executes its transactions. All right, let's look deeper into what each of them are. So this is a quote our founder, Sylvia McCauley, said in one of the fireside chat. So the moderator asked him, hey, why isn't Algorand using EVM? Like, why aren't you doing it? Because that's the most widely used virtual machines out there. Well, this is what he said. He said that nothing can be more pernicious than premature standardization. Blockchain technology is a new technology. And EVM is great. It's powerful, and it does great at what it's doing. But it doesn't cover every use cases. And in such a new technology, we need to cover everything that the blockchain could be used for. And the Algorand has a mission to create a global frictionless economy. And we thought building our own virtual machine to suit our need was necessary. So let's talk about some traits of Algorand Virtual Machine. So Algorand Virtual Machine evaluates a smart contract using the Teal programming language, again, which is a low-level language that it can easily understand, and that's what makes Algorand so fast. The AVM provides about 160 plus opcodes, and more is coming with latest updates, and that's on par with what the EVM provides. AVM also supports up to 512 bits of mathematical precision. What that means is it just can handle large numbers, so you can be more precise with your application. Next, atomic transactions. Again, AVM is the reason why you can handle multiple transactions simultaneously, and that is a critical feature that the Algorand provides. With AVM, transaction is 3.7 seconds, and it's instantly final. It can handle 6,000 transactions per second, and the transaction fee is 0.001 algo. That is a fraction of a cent. So that also allows business logic such as, hey, I'm going to pay this transaction fee for my customers because it's not too much. It still makes sense. You don't have to pay a lot for the gas fees. All right, let's go up a layer, and let's talk about smart contracts. This is what most developers will be interested in. So on Algorand, smart contract has a unique architecture. So on Algorand, smart contracts has two programs included in it. One is the approval program, and this is just a program that contains most of the core logic of your smart contract. So most of your code will go here. But Algorand has another program called the clear program. The reason why this exists is because Algorand has this feature called opt-in. What that means is an account can opt into a smart contract, and that allows the smart contract to write local state for specific for that account. Because this feature exists, we need to let these accounts opt out of the smart contract. Now, it's possible with a different application call, but sometimes smart contracts could prevent an account to opt out of the smart contract. Now, that's where Clear Program comes in. It handles that special case where if an account wants to forcefully opt out from a smart contract, they use the Clear Program and they send a clear state application call. But mostly, this Clear Program is not really used for applications, but it's still there, and I wanted to address that. All right, PyTeal. PyTeal is the main smart contract language on Algorand. And PyTeal basically lets you write smart contract in Python-like code. Now that gets compiled, if you look at the diagram here, that gets compiled down into Teal source code, which is automatically generated, and that gets compiled down into bytecode, which is executed and understood by the Algorand virtual machine. But we kept asking the question, can we make smart contract development easier? Because we're not here to grasp Web3 developers. We want to teach Web2 developers who know nothing about blockchain. Well, that's why we introduced a Beaker framework. So a Beaker framework is a Python smart contract framework that makes your smart contract code just like a Python class. It also makes your deployment and interaction code with your smart contract a lot simpler. And it also provides tooling for debugging. So in short, it basically abstracts all the complexity that you don't really have to worry about, and it just lets you focus on the business logic of your smart contract. So I just want to show you a simple smart contract. This is a complete smart contract that is both using Beaker and PyTeal. For those of you Python developers, this should look familiar. It's basically a Python class named Hello Beaker. It's inheriting from this application class. It has one method called hello, and is decorated with the external decorator. Now, I want to highlight the part where the Beaker is coming in. So that part right there is what Beaker is doing. Without Beaker, your code wouldn't look like a Python class. It would have to create this thing called router class, and you have to route all of your application calls into your method. It's complex, I promise you. Well, Beaker abstracts away for you. And you can just write a smart contract like a Python class with Beaker. And that part is where PyTeal comes in. PyTeal is used to implement the functionalities of your smart contract. So Beaker is for organization, PyTeal is for the actual functionality. All right, I want to do a deep dive into that same smart contract. I don't know if you guys can see this. I'm sorry. But it's the same smart contract that you just saw in the previous slide. So what I'm going to do here is I'm going to instantiate that smart contract, and I'm going to dump out 3 files. One, a contract.json file, an approval.teal program, and a clear.teal program. So let's see what that looks like. So this is the approval program. This code is automatically generated from your PyTeal and Beaker code, but this is basically what the AVM will be executing. So most developers really don't have to understand this code, but for those of you, those people who want to go dive deeper, you can actually make direct changes to this code to make your edits. All right, let's take a look at Clear Program. As you can see, there's nothing there. That's because in the smart contract, we don't have any logic that handles the clear state application call. So most Clear programs will look like this. And then the third file that is spit out was the contract.json file. This is an ABI. You don't really have to read through it, but I'm going to cover ABI in the next slide. But basically, this is a standard that tells your front end how to interact with your smart contract. All 3 of these files were automatically generated from your PyTeal and Beaker code. All right, going back to my slides. Let's talk about ABI, just like I said. So Algorand ABI is a standard that defines how to call smart contracts, and it also automatically encodes and decodes data when it's moving back and forth from the front end to the smart contract. So what does that mean? It just means, hey, front end, I have all the rules and all of the methods that the smart contract has. This is what it is. This is what you have to provide for the arguments, and this is what it's going to spit out. This is what it does. It tells the front end that, and it makes the front end's life a lot easier. So ABI is just used in the middle to make that interaction smoother. Okay, let's take a look at the example of the ABI. This is the ABI from the Hello Beaker smart contract that we just saw before. I want you to focus here in the middle. So right there is what's called a method. So this method shows an expected arguments that this method takes in and the return type of that method. So as you can see here, the name is hello, same as what you saw before. The arguments has the variable name is name, and the data type of that is string value. And when you look at the returns part, the type of that return value is a string value. So that's how the front end knows what to expect. All right. Zooming out a little bit more, that's an interface. So this smart contract only has one method, but if your smart contract was to have multiple methods, all of your methods will be included in this interface. An interface basically shows a collection of methods that defines a standard for other contracts to implement. So let's say I created a template for NFT auction app. The interface will show, hey, if you want to create an NFT auction app, these are the methods that you need to have. And on top of that, you can add more methods if you want to customize it. Zooming out more, that's a full contract. So that's the full implementation of the deployed contract. It includes all of the details that you need to know to interact with that smart contract. All right, let's go back up. And now let's talk about the Algorand SDK wrapped with Beaker. So Algorand SDK is what you use to deploy and interact with your smart contract. So mostly you will be writing this code on the front end side saying, hey, like this is the method that you call to interact with your smart contract. Algorand officially supports 4 languages for the Algorand SDK: JavaScript, Java, Python, and Go. But our amazing community who are passionate about Algorand, they created their own versions of SDKs in different languages like C++ and PHP. So if you're those developers, you can use those as well. But for today, I want you to focus on the Python Algorand SDK, because that's what Beaker is wrapping. Just a quick look at what the Beaker framework contains. For components that does with smart contract, it includes the application class, state, and decorators. So these are all helper tools that you can use when you're writing smart contracts. For deploying and interacting with your smart contract, it provides what's called an application client. And for testing, it provides Sandbox. So Sandbox lets you create a private local blockchain on your computer so that you can quickly test your code in a safe environment. Well, today, I'm just going to talk about the application client because I think it is the best feature that Beaker provides. All right, so you see a lot of code, but let's break this down. So the code right here, what it's doing is basically it's going to grab 3 preloaded accounts from Sandbox. So Sandbox, it lets you run a private local blockchain on your computer, but it gives you 3 accounts with algos loaded in it so that you can play around with it to test your code. So all it's doing is grabbing that and it's taking 1 account from those 3 lists. And then down there is setting up the Algorand client, and that client is what lets you interact with that blockchain. And down here, we're using that account and the Algorand client and the instance of the smart contract to create what's called an application client. So what is an application client? It's basically a convenient way for you to interact, deploy your smart contract. So if you look at the definition of the application client, these are about 20 helper functions predefined, just ready for you to use right out of the box. So without Beaker, if you were just writing smart contract with PyTeal, you would have to manually write all these code on your own. And that is saving you about 750 lines of code just for using Beaker. So code right here is a demo of a full life cycle of a smart contract. Let's highlight the part where it's actually using the application client. On the top, it says app client 1.create. So what that's doing is it's deploying the smart contract to the blockchain. Down there, we're funding the smart contract. We're opting into the smart contract. We're also calling a method from that smart contract called setNick. And down there, it's getting the application account info, closing out from the app, and then finally deleting the app. Well, what I want you to get out of this is that all of these interactions, deploying, it was done with one line of code. You don't have to manually set up transactions, sign the transactions, send the transaction to the blockchain, and wait for confirmation, which you would have to do without Beaker. The application client handles this for you, so you can just write simple one-liner code to actually deploy and interact with your smart contract. Okay, so I want to go back to VS Code now and see that interaction code. So I'm going to go into interact.py. And the code here, I'm going to quickly run through this. So first, I'm instantiating the Hello Beaker smart contract here. And then I'm creating the application client, just like we saw in the previous slides. I'm assigning that into app client variable. This line of code right here, app client.create, is going to deploy that smart contract. And it's going to spit out 3 values, an app ID, an app address, and a transaction ID. And app ID is a unique ID that the smart contract has. App address on the Algorand smart contract is basically an account, so you can send algos and ASAs to the smart contract. So if you want to do that, you would send it to this app address. And the transaction ID is a transaction ID where the smart contract was created. And then down here, all it's doing, and we're calling the hello method, and the argument is Chris, because that's my name. And we're going to print that value out. So let's go to a terminal and see what happens if you run this. All right, so I just ran that file. I have Sandbox running in the background, so I have a private local blockchain running. And basically what I just did there is I deployed that smart contract to the Sandbox blockchain. The transaction ID is that. It has the app ID and the app address right there. And it's spitting out hello Chris, just like we expected. All right, that's it. So let's do a quick recap. What did we learn today? We first talked about the general strengths of Algorand, and then we went into what a dApp architecture looks like on Algorand. It's not too complicated. It has the 3 components the Web2 application has. You're just adding the Algorand blockchain and a smart contract to that. And then we dive deeper into the blockchain layer of it, and then we went through each one of them to see what they are. We first talked about the Algorand virtual machine, why we chose to build our own virtual machine, why it's fast, why it's cheap, why it's secure. And we talked about Teal, which is the assembly language that the AVM understands. Going up a layer, we talked about what smart contract language you use to write a smart contract. It's PyTeal. It's a Python-like language, but you wrap that with Beaker framework to make it more familiar for Python developers. And then you use the ABI from the front end to know how to interact with your smart contract, and you do that with the SDK wrapped with the Beaker framework. Well, that's it, guys. I hope that my presentation today has given you a complete understanding of what dApp development looks like on Algorand. Please do take the time to scan these 2 QR codes. The QR code on the left is an all-in-one Algorand developer resource. You'll find the presentation slides in that link as well. Also, do scan the QR code on the right. That's going to take you to all of my social media profiles, my Twitter. I'm definitely not doing this to increase my Twitter followers, but please do follow me. But jokes aside, I'm doing this because I want to connect with you guys. If you're entrepreneurs, I want to help your developer team to build an application on Algorand. If you're developers, I want to directly help you. I want to help you debug. I want to help you create the best smart contract that you can build on Algorand. Well, that's it, guys. I'm going to leave that up there for a few seconds, but thank you so much for listening to me to the end. It was a long presentation, but thank you so much.